These are the solutions for chapter 4.2. Let's go ahead and start with problem number 14. Chapter 4.2 continues from 4.1 and talking about linear correlation. And now the idea is that we're going to use, once we know that there is correlation, we can use those ideas to make predictions about the world given the um, association between those variables. And so first example here would be, does study time affect exam scores? And so some professors surveyed 14 students to find out how much time they spent studying for exam and then their exam score. And then they calculated the least squares regression equation or line. When it says that, we're talking about the equation, and StatCrunch would do that for us. And so looking at that right now, um, predict an exam for a student who studied 2 hours. Well, after putting in the data, here is your regression equation right there. This is the least squares regression line. It is again the line that comes up in StatCrunch. And so in this case, your y value is your exam score, and your x value is hours studying. And so that's what those values mean there. And so for part A, the equation is really to predict an exam score for someone who studied 2 hours. You just do 6.3333 and then put 2 in its place, since the x value is hours studying, plus 53.02. My pen is acting up right now. 298. Sorry for the writing. And so the score that would be predicted would be approximately 65.7. That's if someone studies 2 hours. Interpret the slope. Since the slope is 6.33, 6.33, what this means is that for each additional hour of studying, um, the exam score will increase on average 6.33 points. So if you want to increase your score, you study more, and that's what this equation is saying. Doesn't mean it's going to predict perfectly for everyone, but on average, this is what we would expect to happen. Part C, what is the mean score of students who did not study? So if you did not study, that means x equals 0. And so all you do is you substitute into that equation, x equals 0. And if you remember your algebra, that's really the y-intercept. And this is what's really going on here. We have the y equals mx plus b. It's a linear equation, so we're going to have that. And so if someone doesn't study, on average, they would score 53.0298. And then part D, what's the answer for part D? A student who studied 5 hours for the exam scored an 81. Is this student's score above or below average? So what we're going to do in this place, we're going to predict what we would think a student would get if they studied 5 hours. And so if you substitute 5 into that equation, you get a score of 84.7. And so what that means then is that we would assume the student scored below average for somebody who studied 5 hours, because they scored an 81 and what we would have expected is 84. This is problem number 18 for chapter 4.2. So we're now at problem number 18. We're going to need StatCrunch on this because we're going to need to calculate the least squares regression equation or line, which was already done for us here. Now we're actually going to calculate ourselves. And here's the idea that at some point you have a credit score. You might have one now, but the idea is that your better credit score is a higher score, and that if you have higher credit, which means you have better credit, people are willing to lend you money at better interest rates because you're more likely to them to be able to pay it off, because you're more reliable, dependable, and that's what that high credit score may mean. You have a good job, make money, you're paying your bills, and so they're willing to lend you money. You can see if you have a higher credit score, you have lower percent. Low credit score, you're going to charge you a penalty by charging you more interest. So is there a relationship between credit score and interest rate? So first thing we want to do is find the line, the least squares regression line, treating FICO score, that's what it's called, the FICO score, your credit score, and as the explanatory variable, and the interest rate. And so we're going to do that. So let's go ahead and open up StatCrunch. Let me open up that data. And so from here, what we have is your information here. It's not a lot of data points, but we'll use that anyways. And so we're going to do a regression, simple linear. X is your credit score, and does that predict your interest rate? And we're going to go ahead and compute. And when you compute that, we will see a graph, which definitely looks like it's a negative association. The better your credit, it's actually negative in the math sense, but it's actually positive if you have a better credit score, right? You have a lower interest rate. And then looking back here, we end up with a couple of key values here. We end up with these values right here. Let's see if I can copy paste that. There's an equation right there that we're going to use for part A right here. And so let's go ahead and get it in right there. So for part A, right here, we had using that information. For part A, we can say your equation is, I'm going to use different variables here. So you can say y is equal to, that's your y value, and this is your, sorry, let's repeat that. Your y is your interest rate. Your credit score is your x. So y is equal to 61.369. I'm going to go to 3 decimal places, minus 0.076x. And I just use, there's your credit score is variable x. Your interest rate is variable y. And so there we have that, and there's your correlation coefficient, close to -1, which is mean really strong. So that's your answer for A. Interpret the slope and y-intercept in this case. And so I think for question B, what the slope means is for each one point increase. There we go. For each 1 point increase in credit score, you can expect the interest rate to decrease. How much is going to decrease? It's going to decrease by 0.07 0.076%. And I got those numbers from right there. Okay, and then the y-intercept, what does the in this case the y-intercept mean, which is the question here? What does the y-intercept mean? A credit score of 0, a credit score of 0, a credit score of 0 is not possible because they only go from 300. So y-intercept occurs when x equals 0. So you need to remember that y-intercept occurs, and that's from algebra, occurs when x equals 0. So technically this value has no meaning because a credit score of 0 is not possible. So the y-intercept in this case has no meaning. Sometimes it will. So has no meaning in this case because you can't get a credit score of 0. Okay, so we'll have to pay attention to that as we move on. And then part C, predict the credit score, predict the interest rate of a person who will have a FICO score of 723. And so all you do is just substitute into that equation up above, y equals 61.369 minus 0.076, and in place you're going to put in 723, and you get an approximate value of 6.13%, somewhere in there approximately. And so that's the percent you would predict for somebody. And then part D, see if we can squeeze it in right there. Suppose Bob has a FICO score of 680. So if we plug 680 into this equation, and so you can see we're using these the least squares regression line. If we plug in 680, we would expect someone to have an approximate interest rate of 9.42%, about that. And so if that's the case, Bob has 680, he would expect 9% on average, but in this case, he's offered 8.3. So in this case, we would say, I would say 8.3% is a good offer. It's a good offer because it's lower than what we would expect. He would expect 9.42 with a 680 credit score. Okay, this is problem number 29 from 4.2, chapter 4.2, problem number 29. And so now we have a relationship between square footage of a home. And so we think is the bigger the house, the more it will sell for. And this is for the same city in Florida. And so let's take a look. Is there a relationship between those variables, the explanatory and the response variable? So in this case, the first question that's being asked is which variable is the explanatory variable? And it's already given away here. But in this case, square footage, or the size of the house, right? Square footage is the explanatory variable. And does that explain the cost of a house? So that's what we have there. Part B, draw a scatter diagram. So we're going to go back to StatCrunch, problem 29. Let's get the data in. Again, that will come from your textbook. Okay, that's one advantage of using the online textbook, is it enters the data in quickly for us. We'll get there. There it is. So the data gets put in. And so we're going to go ahead and create a scatter graph. We're going to do a simple linear regression, square footage and selling price. Let's compute. And so we look to see if there's a relationship. We'll go ahead and again look at the graph, and it does look like we have a positive association between them. And so there's our scatter diagram that we would want. Oops, I can't do that, sorry. There's a scatter diagram that we would want. And so you see the positive association between that. So let's go ahead and get that in. And then, of course, the next question after that's going to be, do we have a, what's the correlation coefficient? What's the equation? We're going to have those questions to answer. And so we have that there. And so let's go ahead and let's paste that in. So you make sure you have the graph, some quick sketch. Again, on paper, just make a quick sketch. So there's our graph for that. We definitely have a relationship. So that's your part B. Determine the correlation coefficient between them. And so let's go ahead and do that. The correlation coefficient in this case, if we go back, we'll grab all of that. We're going to grab that correlation coefficient and the equation there. We're going to need that. So let's get that so we can work on do some math here. And so let's see what we got here. So this is, so there's the information we need. And so from here, there's the graph. And so the first question is asking us part B. That was part B. Part C is asking us the correlation coefficient. R is equal to right here. So we'll go 0.903. We'll go 3 decimal places. Is there a linear correlation between square footage and asking price? So what's the sample size? Sample size is... So sample size in this case is 2, 4, 6, 8, 10, 12. We have 12 homes in the sample size. So what's the critical value of that? The critical value of that, we need to pull it up on a table. And StatCrunch, I think, gives it to us. Let me see. Oh no, yeah, we would find it. But the critical value, again, for size 12, hopefully we have it in our notes. Otherwise, I got to pull it out on another one. Here it is. Critical value size 12 is 0.576 using our table from our notes. And so we know the critical value is 0.576. Let's go ahead and take a look. So in here, the critical value is 0.576, 0.576. So yes, we do, because 0.903 absolute value of that is greater than 0.576. We don't really, because it's positive, we just want to compare. If it was negative, we need to take the absolute value. Part E, find the least squares regression equation. There it is right here. X is square footage, Y is selling price. So you get Y is equal to 14.874 plus 0.156x, and I'm using for X and Y. I'm getting them from right here. That's the equation. That's E. F, interpret the slope in this case. So looking at this one, so we would say for the slope, for each square foot that for each square foot that is added, the price of the home, right? The price of the home increases 0.156. What is the unit here? Thousandths of a dollar. So so it increases 0.56 thousandths of a dollar. I know it's kind of weird to interpret. Or $0.56,000. That's like multiplied by 100, multiplied by 1,000. It's like $1.56. Okay, and then G, what's the y-intercept in y? In this case, it is not reasonable, because reasonable, since x cannot be equal to 0. That means no home. So there will be no home, so you can't do that. And then H is our last question here. And for H, we would put one home that is 1465 square feet is sold for 285. 250,000, is this above average or below average? So what you're going to do is you're just going to plug in. You're going to plug into this. In place of X, you plug in the square feet, because X is our square footage. When you do that, you get an approximate value of 243.8532, and because that is less than that, since it's less than the price, we would say 285,000 is above average. That's what we would say. It's above average.